to continue understanding CMYK color separation, right, we are going to, last video talked about the difference between how professional lithography presses print, which is like this, versus how digital prints print, right? And I showed you how you can kind of use the best of both and integrate them into your work. Like so. All right. If you go to assignments where we have kind of our supplemental and helpful materials, usually as Google Slides, which you can make your own copies of if you want to have them after the semester ends, you scroll down to assignment 6, that poster that we just did, you'll see an exhaustive explanation of CMYK color separation. So these are some slides I put together. CMYK stands for cyan, magenta, yellow, and black. Those are the 4 inks used in commercial printing. But you need to understand the difference between how you see things on the computer screen, which is with RGB color, and how things are printed commercially, which is with CMYK color. RGB stands for red, green, and blue. Red, green, and blue are the light primaries. So when you're looking at colors on your computer screen or on a projection, you are looking at light. And there are 3 colored lights your device needs, your screen needs, to show you the millions of colors that your eye can perceive between infrared and ultraviolet. They are red lights, green lights, and blue lights. Now, how do we get the other colors? Well, when those lights overlap, like red and green at 100%, you get yellow at 100%. That's because light is additive. The more you add, the brighter it gets. So you'll notice that the yellow is a much brighter color than the red and the green. Because you add light to light, it gets lighter. And if you add all 3, red, green, and blue at 100%, you get white light. Like your phone, when you turn your flashlight on and it drains your battery really fast, that's because all the red, green, and blue pixels on your phone are turned on at 100% fully for that flashlight. It doesn't quite work because your flashlight doesn't come from your screen, but you get the idea. It's a lot of power to get white light. Now, how do you get black? How do I see the black on this projected image or on my screen? Or you're looking at the YouTube, you're looking at RGB pixels right now. Black is when those lights are turned off, right? Black is the absence of light. Now, you can't print light. So when you print, you have to do an imitation of those colors. And we have to do it with pigment, the same way you would with markers or with paint. We just use printing inks. And the closest we can get to that range of colors, these are called the light primaries. So RGB are the light primaries, are CMY. Cyan, magenta, and yellow are the pigment primaries. These are the colors that can mix other colors with pigment, whether they're paints, whether they're crayons, whether they're inks, or colored pencils, right? So if you mix cyan and magenta ink, you get purple, right? If you mix magenta and yellow ink, you get red. Superman's cape is printed with 100% magenta ink and 100% yellow ink. It's called 100% red. To get green, you mix cyan and yellow. All of that makes sense. How do you get black? It's kind of a trick question. You can get close to black by mixing cyan, magenta, and yellow all at 100%, but what you really get is just kind of a muddy brown. So we add a fourth ink. It's not a color, black isn't a color, but we add black ink on top to help increase that visual range. Black doesn't give us different colors, but it gives us different values to those colors. So color separation is then taking those inks and then separating them into dots so they mix at different frequencies, different ratios. If we do it with just one color, then we can get the different kind of illusion of grays. But if we do it with multiple colors, those colors can mix to give us different colors. This is an artist that's worth looking at. He creates the work digitally and then uses the digital film work to make silk screens that then he prints with solid inks onto cardboard, which then he photographs and animates. And it's a really intense process to get these animations, right? Which start digital, then end up as colored prints on cardboard that are layered up. But you can see how the color separation of cyan, magenta, yellow, and black are all used in his process. This is not color separating. This is just cutting out the shapes of the color and then thinning them out. Color separating is not this. Color separating is mechanically separating them into dots. Not that. This. So this is done through bin Day dots, named after printer Benjamin Day. And in order to thin out the black ink, since you can't thin it out, you just spread it out with tiny dots and it looks more gray. And the closer those dots are together, the bigger those dots are, the darker the gray. And when they eventually all come together, like his horn-rimmed glasses, you get these shapes of solid black. We can do this also with color. So, there are different ways to color separate. This is what's called an indexed diffusion, which is like a randomized pattern. This is done through computer algorithms. The more typical way is through the halftone separations. So that's what I'll be showing you. That's what we see in most mechanical reproductions. Halftone just uses dots on a line like bricks in a wall. And it's called halftone because at the most common angle, which you see here, the 45-degree angle that's used traditionally for black, it's like lines of bricks in a wall where each line going down is moved by half. So they're offset by each other by 1/2. Now, this image, professionally printed for like a color manga cover, this is actually what it looks like up close for the eye, and it's separated into these 4 inks, cyan, magenta, yellow, and black, CMYK. But they're all at different angles. Yellow is at 0, cyan is at 15, magenta is at 75, and black is at 45. The reason you line them up that way is so it's not that the dots are just printed on top of something else. The whole image is created from the dots. And those dots create what are called Gaussian roses. So even in this just gray photograph of a rock, the way that's printed is through these 4 inks at these different angles, all lining up so that they somewhat overlap, but mostly offset, so you can see the pure color, so they optically mix at a distance. So even grayscale, when printed for best effect, is using all 4 inks, just like a color image. So here you can see flat color, here you see flat color with offset color on top, and here you see it just like kind of traditional printing on newsprint, like old comics, with it done. So this is the final step. We've done everything through here on the last 2 projects. Now we can get it ready for commercial printing by adding CMYK color separation and understanding it. All right. Some resources. What do you need to remember for the final? You need to remember this. These screen angles. That black is always at 45, and that the other colors are never closer than 30 degrees from black. So if you go 30 degrees down from 45, you get 15 degrees, which is what cyan is printed at. And if you go 30 degrees up from 45, you get 75 degrees. That's what magenta is printed at. And then you just have to remember that yellow is always at 90 or 0. It's the same thing. Yes, so this is under assignments, not under unit modules, but under assignments. That's where all the supplementals for each assignment are. And you'll find it, it's called an exhaustive explanation of CMYK color separation. It's under assignment 6. And then, of course, I'm posting this video too. Okay.